Good day, class. Today, we're going to continue our discussion regarding the different mathematical tools needed in the study of physics. As you journey studying the various concepts regarding physics, sometimes physics problems require you to use the concept of trigonometry. But before we move on to the deeper discussion of that particular mathematical tool, let's go ahead and define the word trigonometry. In terms of its etymology, the word trigonometry came from three Greek words. Tri means three, gono means angle, and metron means measure. If we're going to synthesize these three Greek words and its meaning, we can all agree that trigonometry has something to do with measure of triangles. But in particular, trigonometry is a mathematical study of the relations of the magnitudes of the sides and angles of right triangles. But before we identify how we can compute the magnitudes of the sides of this particular right triangle and the angles of it, let's first identify the different components of the right triangle. By merely looking to this illustration, we can actually say that there are letters, and these letters represent sides, points, as well as the name of a given triangle. So the name of this given triangle, as pointed by the cursor, is triangle ABC. And this is indeed a right triangle. Remember, in order for us to properly identify its parts, sides of triangle are identified relative to an angle. So this is the angle, and we know for a fact that this angle is equal to 90 degrees. So using that, using this as a reference point, this particular right triangle indicator, we can say that the opposite of this is the small letter C. So we can tag this as your side C. Now, the adjacent part of this right triangle are your sides A and B. Now, to further intensify these parts of a given right triangle, we have to note that legs are the term used for the sides of a right triangle adjacent to the right angle. So, using this illustration, we can say that the legs are A and B because these sides are adjacent to this right angle. Now, this side C is your hypotenuse because hypotenuse is the term used for the side of a right triangle opposite to the right angle. As mentioned earlier, the opposite of this right angle is your small letter C. And again, this small letter C means your hypotenuse. Or, to make it simpler, this small letter C or your hypotenuse is known to be the longest side of a given right triangle. Now, let's go ahead and try to use what you've learned from how to identify the different parts of a given right triangle, like your legs and your hypotenuse. But you have to be mindful that your legs are adjacent to the right angle, while your hypotenuse is the side of a right triangle opposite to the given right angle. Now, let's take a look on this given right triangle. So this is our right angle. Opposite to that is your small letter c. Therefore, this is our hypotenuse. And adjacent to this right angle are your legs A and B. So therefore, legs are A and B and hypotenuse is C. Now, for second example, let's try to analyze this particular right triangle. Now, this is your indicator for right angle. Opposite to that is your small letter F. That means your hypotenuse. Adjacent to this right angle are your legs E and D. So therefore, we have legs D and E and hypotenuse F. Lastly, let's try to identify the components of this particular right triangle. Let's name the legs and the hypotenuse. This is your right angle. Therefore, adjacent to that are legs H and J. And opposite to that is your small letter O. So we can all say that legs are H and J and hypotenuse is O. Hopefully, things are clear here. Everything is clear like a crystal clear. It was mentioned a while ago that trigonometry can help us to identify the unknown values of the sides of a given right triangle. Now, to do that, we have to use the concept of Pythagorean theorem. So this Pythagorean theorem will help us, guide us to identify the numerical value of unknown sides of a given right triangle as long as there are other values present. It says here that the square of the hypotenuse is equal to the sum of the squares of the two sides. From the given statement, we can actually come up with a general equation which is a squared plus b squared is equals to c squared. What does this mean? It simply means that whatever the summation of your a squared and b squared, that is just equal to the square of your hypotenuse or your c squared. Now, there are chances that you have to solve for leg A, leg B, or even leg C. So how can we do that? What formula or what equation can be used to solve for those unknown legs? From this general equation as pointed by the cursor, we can derive the following. A for B and for finding C. Now you might wonder how we have these equations. Now, to give an heads up, we just derive it from the general equation by applying the rules of manipulating equations. And that will be further intensified in our next mathematical tool. For the meantime, what I'm going to teach here is just the different equations used to solve for finding A, finding B, finding C of a right triangle. So, for finding A, we have A is equals to square root of C squared minus B squared. For finding B, we have B is equals to square root of C squared minus A squared. Now, for finding C, we have C is equals to square root of A squared plus B squared. So what you're going to do here, as long as other sides are given, you can plug there the values of those known sides in order for us to solve for the unknown values by merely applying the operations provided in each equation. Other than Pythagorean theorem, to solve for unknown values of legs angles and the hypotenuse, the 6 trigonometric functions can be applied. These are as seen here in the given table. We have sine, abbreviated simply as sin or sin, and the way to solve for the value of sine with respect to the angle theta is opposite over hypotenuse. We have cosine, abbreviated by cos. Cos angle of theta is equals to adjacent over hypotenuse. We have tangent, abbreviated as tan. Tan angle theta is equals to opposite over adjacent. Second, abbreviated as sec. Sec angle theta is equals to hypotenuse over adjacent. We have cosecant, CSC. CSC angle theta is equals to hypotenuse over opposite rather. For cotangent, we have cot. That's the way it was abbreviated. Cot angle theta is equals to adjacent over hypotenuse. So, to make life easier, we can apply this simple acronym in each trigonometric function. We have so, ka, towa, and ko, sha, kao. So, S means sine, O means opposite, H means hypotenuse. Your A here means your adjacent. So, you just simply follow everything here so that you can easily identify the equation you can apply if you're looking for the value of sine with respect to the reference angle. Now, also, you can check here that the first 3 trigonometric functions are just the reciprocal form or inverse form of the second 3 trigonometric functions, namely secant, cosecant, and cotangent. Now, you might wonder, how can we identify the legs for opposite and adjacent with respect to the angle theta as a reference frame? Okay, now let's go ahead and take a look on this illustration having this given right triangle. So we have this right triangle ABC, and you've noticed that there are small letters for your legs and hypotenuse. This is your angle theta, our reference frame. Okay, so this will guide us to picture out properly the equation for sine, for cosine, for tangent, so on and so forth for this particular right triangle. Okay, so again, if the right triangle, the position of your angle theta is different from this, so there's another version for solving for sine, cosine, and other trigonometric functions. But again, what you have to remember here is you have to use the position of your angle theta as your guide to identify which is opposite, which is adjacent. We know already how to identify your hypotenuse. That is just the longest leg in your right triangle. Now, let's go ahead and identify the equation for your sine theta here. From what you've learned earlier, your sine is equal to opposite over hypotenuse. So, your opposite here in reference for your angle theta is A, your hypotenuse is C. Therefore, we have sine theta is equals to opposite over hypotenuse equal to A over C. Now, let's try to identify the equation for your cosine using this right triangle. Still, we have to use this angle theta position as our guide. Now, remember, your cosine is computed using adjacent over hypotenuse. Your adjacent here is letter B. Your hypotenuse is still your letter C. Therefore, we have cosine theta is equals to adjacent over hypotenuse equal to B over C. Now, the third trigonometric function is your tangent. Still, we have to apply this angle theta, we're going to identify the letter corresponds to your opposite and your adjacent because that's the way we solve your tangent. Now, your opposite is A still, your adjacent is still B. We have tangent theta is equals to opposite over adjacent equal to A over B. The other trigonometric functions as mentioned earlier is just the reciprocal form or inverse form of the first three trigonometric functions. And those are your cosecant, your secant, and cotangent. Your cosecant is calculated as hypotenuse over opposite. This is still our guide. Your hypotenuse is C. Your opposite is still A. Okay? We have cosecant theta is equal to hypotenuse over opposite equal to C over A. For your secant, we compute that using hypotenuse over adjacent. Our hypotenuse still is the C. Our adjacent is still the B in response to the position of angle theta. We have this equation. Secant theta is equal to hypotenuse over adjacent equal to C over B. Now lastly, your cotangent, we compute that as adjacent over opposite. Adjacent to angle theta is B. Opposite to that is A. So we have cotangent equal to adjacent over hypotenuse equal to B over A. So again, this first three is just the inverse form of the last three trigonometric functions. Now we can picture out na how can we identify values involved for your trigonometric functions with respect to your angle theta. Just to give you a heads up, do not forget the concept of your Pythagorean theorem as well as these trigonometric functions because there are problems seeking for values for legs, for angles, as well as for your hypotenuse. So be mindful about those things, but nothing to worry. We can further clear things up by applying things we've discussed about trigonometry. Now let's have examples. For example number 1, given the right triangle below, find the unknown side and the values of 6 trigonometric functions with respect to angle theta. So here's the illustration. We have values for hypotenuse and for leg B. So we don't have value for leg A. By merely analyzing the illustration, we can all agree that we can jump in solving the values of 6 trigonometric functions because we don't have value for A. Likewise, we can't use any one of the 6 trigonometric functions in solving for value of A because we don't have value for angle theta. And maybe you're wondering why. Later, that will be further intensified. So, for the meantime, the right thing to do here to solve this problem is for us to use the Pythagorean theorem. So, nothing to worry about how to get the value of A from that general equation because we already have a formula for finding A for this particular right triangle in relation to Pythagorean theorem. So, A is equal to square root of Z squared minus B squared. So, we have to substitute the values for C and B. We have this solution. A is equal to square root of 9 centimeters squared minus 6 centimeters squared. So doing the operation here, we have this. A is equal to square root of 81 centimeters minus 36 centimeters. Likewise, do the operation to simplify it further. We have A is equal to square root of 45 centimeters. Again, we don't have direct answer for square root of 45. What we're going to do here is to still get the value of square root of 45, and we have to write it in terms of decimal form. That is still acceptable. So that is A is equal to 6.71 centimeters. Now we have value for leg A, and that value of A, we computed that using the Pythagorean theorem. Now what we're going to do next is for us to revisit the statement of Pythagorean theorem, and we're going to double check that if that is true and correct by using the values we've calculated from this particular example. So using this illustration, nothing to worry, we have values for legs A and B, and we have value for hypotenuse. And this is the general equation for your Pythagorean theorem. A squared plus B squared is equal to C squared. And it means that the summation of A squared and B squared is just equal to C squared. So whatever the value here, when you add that, when you get the square of it, that is just equal to the square of the hypotenuse, or C. We have to double check that if that is true and correct by merely using the values we've calculated earlier. Now, we have value for A, we have to square it. For B, we have to square it. And for C, we have to square it also. What we're after again is for us to see if the values for A squared and B squared once added is just same with the square of C, or the square of 9. So, by doing the operation, we have 45.0241 for your 6.71 raised to 2. And for your 6 raised to 2, we have 36. Adding this, we have 81.0241, or simply 81. What we know, the value of 9 raised to 2 is just 81. Therefore, the Pythagorean theorem is really correct in terms of this particular example. So, Pythagorean is really applied in this right triangle, and for this particular example, which is our example number 1. So we don't have any problem. I hope we don't have any problem by checking things up here about Pythagorean theorem and the equations in solving this particular example or the other examples in the near future. Now, we can go proceed to solving for the 6 trigonometric functions. And this is again the given triangle, right? Triangle. We have to get the value of sine theta with respect to the position of the angle theta here. So sine is opposite over hypotenuse. So we have the values. Just substitute it and solve for it. We have this 0.75. Now for sine, for the next trigonometric function, which is the cosine, we have the equation for that, which is adjacent over hypotenuse. The adjacent of this angle theta is B, and hypotenuse is still C. So cosine A is equal to 6 centimeter over 9 centimeter. So divide that, we have 0.67. Now for tangent A, with respect to the position of the angle theta, so that is opposite over adjacent, A over V. The value of A is 6.71 centimeters. The value of B is 6 centimeters. So divide that, we have 1.12. Okay. Now for the other trigonometric functions, our cosecant, that is the reciprocal form of your sine. So that is hypotenuse over opposite. So we have values naman for those things. We have 9 centimeter divided to 6.71 centimeters. We have 1.34. For your second, that is hypotenuse over adjacent, reciprocal form of cosine. In relation to angle theta, our answer is 1.50 because we just simply divide the value of hypotenuse to adjacent. For the last trigonometric function, which is the cotangent, that is calculated as adjacent over opposite. So adjacent of this angle theta is B and opposite of that is A. That's just reciprocal form of tan A. We have 0.89. So here are the answers for the 6 trigonometric functions. And the answer for the unknown side for A is 6.71. I hope everything is clear in this particular example. Now let's have example number 2. Given the right triangle below, find the unknown and the values of 6 trigonometric functions with respect to angle theta. So here's the illustration for the right triangle. So what I want you to do is to pause the video for a while, use your scratch paper and scientific calculator, work on your own. This is just same with what we did earlier with example number 1. And once you're done, you can play again a video and see if you are correct with your answers. Now, let's check if your answers are all correct. Looking to this illustration as pointed by the cursor, we can say that all of the legs have values 8 and 6 respectively. Now, we don't have value for the longer side of this right triangle, so this unknown value is for the hypotenuse. So we don't have problem for that. We can go ahead and use the equation for finding C. So we have this equation C is equal to square root of A squared plus B squared. So substitute the given in this equation. We have this solution. C is equal to square root of 8 raised to 2 plus 6 raised to 2. Now, do the operation, get the value of the square in each number and add them. So you have C is equal to 100. We have square root for that. So that is C is equal to 10. So hopefully you got the same answer. Now for the 6 trigonometric functions, here are the same illustration. You've noticed that we have value now for the longer leg of this right triangle. That is 10. That is based from what you've computed earlier. So we have to get the value of sine. So in reference to the position of the angle theta, so sine B is equal to opposite over hypotenuse. That's the reason why we have 6 divided by 10. Our answer is 0.6. Now for cos B or cosine B, that is, your cosine B is equal to 8 over 10. The answer is 0.8. That is simply because in relation to the position of angle theta, adjacent over hypotenuse. Now for tan B, so that is opposite over adjacent in relation to the position of angle theta. So we have 6 divided by 8. The answer is 0.5. Now for the other 3 trigonometric functions, the reciprocal form of the first 3 trigonometric functions, for this cosecant B, we have 10 divided by 6 because that is hypotenuse over opposite. The answer is 1.67. Now for secant B, so that is just reciprocal form of cosine. So you have hypotenuse over adjacent. So 10 divided by 8 is equal to 1.25. Now, the reciprocal form of tan B, which is your cotangent B. So that is adjacent over opposite. 8 divided by 6 is 1.33. Hopefully, you've got the same answers here for the 6 trigonometric functions. So very good for example number 2. Now, just to give you a heads up, make sure that your final answer is in 2 decimal places. Okay? Now, let's have example number 3. Here, we have to solve for the value of C using the given diagram below. Here's the diagram. So what you've noticed, we don't have value for C. We don't have value for the other leg, which is the leg B. And also, we have value for leg A, which is 5.12. Now, maybe you're wondering how can we work with this particular right triangle. We don't have value for C, for A. What we have here are values for the angle theta and the other leg, which is 5.12. But nothing to worry, we can go ahead and solve this particular number. Okay. Now, what I want you to do here is to analyze what particular trigonometric function can we use here if we're looking for the value of C. Okay, you can pause the video for a while and try to think. Now, good that the answer is the trigonometric function for sine. Now, if we're going to put it into the formula for getting the sine as the trigonometric function that we have to use for this particular right triangle, we have to substitute the given that we can observe from this given right triangle. So we have the value for angle theta, which is 31. So we have sine 31 degrees is equal to, remember, because sine is opposite over hypotenuse. So we have the value for opposite, 5.12. We don't have value for C. So this is the first thing that we can have in order to further work with this particular problem. Now, by analyzing this, we can cross multiply. Then after cross multiply, we have this solution. So sine 31 degrees multiplied to C is equal to 5.12. Now, in order for us to remove sine 31 degrees from this side of the equation, leaving only your C for a hypotenuse, we have to divide both sides by sine 31 degrees Celsius. So, having said that, we can cancel common terms here. So, we can cancel sine 31 degrees on this side of the equation. What we have here is C is equal to 5.12 divided by sine 31 degrees. Now, let's continue our solution. You have to get using your scientific calculator by pressing their sine 31. So what you have there is 0.515038074. No need to write the answer for sine 31 into 2 decimal places and then do the rounding up process. No need for you to do that. The 2 decimal places can only be done in the final answer. Okay? I hope everything is clear here. Now you can divide 5.12 to the value of sine 31, and we have the value for C, which is approximately 9.94. Again, 2 decimal places for the final answer. So we're done getting the value of C, and we're done also solving for example number 3. Again, the technique that we applied here in order to solve number 3 is to look first for the right trigonometric function that we can apply for this particular illustration. having this given. Okay? Now, there are chances that the trigonometric function that can you apply here is cosine or tangent, as long as you properly analyze the position of the given values in order for you to get the unknown value. Okay? So, it is clear that you can only do 2 decimal places for the final answer. Hopefully, everything is clear for number 3. Now, let's have example number 4. So, in number 4, calculate the value of x given the diagram below. So, this is just somewhat the same with what we did earlier for example number 3. But what I want you to do is to pause the video for a while, use your sketch paper and scientific calculator, solve it on your own. And let's see if your answer is correct. Now, let's see if your answer is correct for this example number 4. By analyzing this illustration, this right triangle, we can all agree that the trigonometric function that we have to use in order to get the value of x here in relation to these values as pointed by the cursor is the equation for tan, right? So putting all of these values into this for the tan equation, what we have here is tan 25 degrees. That is the value of the angle theta is equal to x, okay, divided by 15. Why? This is your angle theta. We have to get the value of x, so opposite, and the position of this 15 centimeters leg is adjacent to this angle theta. That's the reason why we have to use the equation for tan. Again, it doesn't necessarily mean that you have to use tan all throughout the given examples. What you're going to do first is to analyze it by looking to the position of the given in relation to the angle theta. Okay, now let's go ahead and work with this solution. Part of the solution rather. So cross multiply this in order for us to get the value of x. So when you do cross multiplication, what we have here is now tan 25 degrees multiplied to 15 centimeters is equal to x. Now again, using your calculator, press tan 25. No need for you to write it in 2 decimal places. What I want you to write is all of those numbers as seen on your scientific calculator and multiply that to 15 centimeters. Now, the answer is the value of x is 7 centimeters. Hopefully, you got the same answer here. Now, let's have example number 5. In number 5, we have to solve for the angle A if opposite side and hypotenuse values are 12 and 25 respectively. So here's the illustration for the right triangle for this particular problem. So we have the values for this leg, which is 12, and the hypotenuse is 25. And what we're after here is for us to solve for the angle A. And there's no problem at all when doing this or solving this particular example, because we've done discussing how we solve the measure of angle theta in this particular concept. Now, what we're going to do here is to analyze again the illustration and identify the right trigonometric function to be used in order for us to solve the angle or the measure of the angle A. And that is still, you have to consider the position of the angle A. So, angle A, we have given 12 and 25. So, that means 12 is opposite to angle A. And this is hypotenuse. So, opposite and hypotenuse. We can all agree that we have to use sine to get the measure of A. Now, what we have here now is sine A is equals to 12 divided by 25. Why 12 divided by 25? Simply because this is opposite and this is hypotenuse. So opposite over hypotenuse, that is the equation to be applied for sine as one of your trigonometric functions. Okay, now moving on, we have to get the value of sine A by dividing 12 to your 25. We have sine A is equal to 0.48. So that's the answer for that. Now, we're not after with getting the value of sine A. We're after with getting the angle A. So what we're going here, as pointed by the cursor, is for us to transpose sine to the other side of the equation. So making it sine negative 1. So what you're going to do here is press in your calculator sine negative 1, okay, and the value 0.48. You have to multiply that. So you can see in your calculator, shift, press sine, so that gives you sine negative 1 multiplied to 0.48. So it should be like this in order for you to get the value of A. Now, after doing this, the answer is the measure of angle A here is 28.69 degrees. Hopefully, everything is clear in this example. Again, what I want you to remember is first, analyze the given right triangle illustration and try to think of a trigonometric function that you can apply in order for you to solve for the angle or the theta. And again, you have to be mindful about the position of the values and transpose the whatever trigonometric function is that, whether it is sine, cosine, tangent, you have to transpose it to the other side of the equation in order for you to get only the measure of angle and multiply it. You can actually use the calculator to do this kind of example. I hope everything is clear. Now let's have example number 6. A wheelchair ramp is placed over a set of chairs so that one end that is 2 feet off the ground. The other end is at a point that is a horizontal distance of 28 feet away as shown in the diagram. What is the angle of elevation to the nearest tenth of a degree? So here's the illustration of this particular problem. This is how we visualize it. So you have given 2 feet and 28 feet. So what you're after on this particular example is for you to look for the angle theta. This is just same with what we did earlier for example number 5. Another thing that you have to consider as for your final answer is to make your it nearest tenth of a degree. Okay? So what I want you to do is to pause the video for a while. Use your scratch paper, scientific calculator, and solve for this problem. Again, you have to be mindful about the position of your given so that you can use the right trigonometric functions to solve for angle theta. And again, also, whatever trigonometric function is that, the angle is still the same. That's a clue. You can start answering it now. Now, let's see if your answer is correct. By analyzing this illustration, our given is opposite to angle theta, and another given is adjacent to angle theta. So therefore, we can all agree that the trigonometric function we have to use for this particular equation is your tan, right? So putting all of those given to your tan equation, we have this tan theta is equal to 2 fifth over 28 fifth. So dividing this given, we have 0.07142857.1. So again, as mentioned before, no need for you to write this into two decimal places because this is still not the final answer. We only do that in your final answer. Now, what we're going to do next is to transpose tan to the other side, making it tan negative 1 multiplied to this in order to get the measure of angle theta. Using your calculator, you can press there shift tan, and what you're going to see in your end is like this. So angle theta is equal to tan negative 1 multiplied to 0.07142857.1. And the answer is correct. The angle is 4.1 degrees. Hopefully, you got the correct answer. And that's the end of our discussion for this particular mathematical tool, which is your trigonometry.